Good morning.
So, if you want to be a clown, you're in the wrong place. Okay? All right, we're looking at our white sheet. The good thing is this is a review from 6th grade, okay, and 7th grade. The only new part in 8th grade is this part right here, okay? All of this is review. All right, so remember that beautiful song we sang? Natural numbers are naturally numbers you count on your hands and your feet. Y'all remember that? Okay, that's the most basic natural numbers, okay? When you're counting by your hands, when you're first learning to count, do you start at 0?
No.
With your hands, do you ever go 0? No. Okay? You start at 1, and you just count up. Okay? You don't count by 1.3, 1.7, 1.9. You count by whole numbers. Okay? These are also called counting numbers. C-O-U-N-T. Counting numbers. Okay, so natural numbers are counting numbers. Okay, a little bit more broad is a whole number. And a whole number is a natural number and 0. Okay, this is where that 0 fits in. It's all the natural numbers plus 0. So 0 is a whole number, even though it doesn't really seem like it's a whole number. It is a whole number. Okay. All right. Integers are next. Again, these words should seem very familiar to you. Integers. Okay. Integers are like -2, -1, 0, 1, 2. So these are all of those whole numbers and their opposite. All the whole numbers and their opposite. All right. And then the biggest set that we know in 8th grade, well, we knew in 7th grade, was rational. Yes. All the numbers that you know of in 7th grade were rational. So these would be like 7/4, -2.5, 9.3 with a line over it. What does that 3 with a line over it mean? Repeating. Okay? So those are all the numbers you knew in 7th grade. They can be expressed as a ratio, which is just a comparison of two numbers. It's a fraction. Okay? That's review from 6th grade, 7th grade. All right? 8th grade, we add in a new word. What do you think the new word we're adding?
Irrational numbers.
Irrational numbers. These are new numbers that we don't know about yet. Okay? An irrational number cannot be expressed as a fraction. Cannot. Okay? Cannot. So we actually talked about some of these numbers on Friday. These are going to be non-perfect squares. Does anybody know what it means to be irrational? Like, to be an irrational person?
Crazy.
A little bit crazy. To be, what else?
I said rare.
Okay.
My mom's
Rare.
irrational.
Okay. So, if someone is being irrational, like Jules is talking about how great Miss Davis is, okay? She just goes on and on and on. She's so pretty, and she's so smart, and she's so funny, and she tells the best jokes, and she's so kind. She goes on and on and on, okay? Irrational means never ending. I'm using that as a positive. But some people are irrational about stuff that bothers them, okay? They never stop. They keep going on and on and on. It's a never-ending number, okay? So, in 7th grade, we actually learned about pi. And remember we told you it was a number that never ends? Pi was an irrational number, okay? So if it never ends, it might look like 2.783 ... Okay? Never ending. It has the ... Those are some examples of irrational numbers. Okay? Can someone give me a non-perfect square? Yeah.
Square root of 5.
Okay, square root of 5. Good. Remember that perfect squares are these guys right here that we did? Those are perfect squares. Okay, non-perfect squares is any other numbers. Okay, I can't think of a number to multiply by itself to get 5. Yes.
Are imperfect squares basically the numbers that don't have halves?
Not necessarily. And tomorrow when I show you a calculator, it's going to be so much easier too. So just go with me for now, but tomorrow I promise it will be much easier. Okay, a rational number could be a repeating decimal. How do you know if it repeats? It has to have the line over it. Okay, it might even be like this. Okay, it has a line over it. It's a repeating decimal. Repeating decimals are rational. Okay. All right. Now, let's think of some more examples. If I said, okay, let's pretend like I saw Sarah at Target. Okay? If I saw Sarah, would she want me to know that I know her? Or would you hide from me? Note to self. Okay. You would hide from me? Okay. I know that Landon would not hide from me. Okay? So, if Landon saw me, and I said, hey, Landon, would he know that I knew him? Yes. But if I said, hey, aren't you in my 8th period class? Would he think I knew him? Maybe a little bit, but not really. What if I said, hey, are you an 8th grader at Richview? Okay, he's like, she really doesn't know me. I look right there at her every day. Or if I said, hey, don't you live in Round Rock?
I've seen you around.
It's very, very, very broad, okay? Numbers want you to be the most specific. If I see you, you don't want me to be like, hey, you're in my 3rd period class. You want me to know your name, okay? Numbers want you to be the most specific, okay? So like the number 0. 0 would go into what category? Whole numbers, okay? Now, 0 is also an integer, and it's also rational, but we want the most specific, the most specific, okay? What about 12 over 4? What does that equal?
3.
It equals 3, so where would 12 over 4 go?
Natural.
Natural, good job. Okay. Where would negative 9 go?
Integer.
Integers. Where would negative 9.7 go?
Rational.
Ooh, good. Didn't get anybody on that one. Where would the square root of 9 go?
Natural.
What is the square root of 9?
3.
3, so it would be natural. Where would 8 over 5 go?
Rational.
Rational, because is that an even number? No, when you divide it, it's going to have a decimal. Okay? Everybody okay with how to put things where they belong?
Yes.
Okay. Oh, let's write some irrational numbers down here. So y'all give me 3 examples of irrational.
5.
Pi. Go ahead. Somebody had their hand raised. No? Okay. Ooh, is 2.3331?
No.
No, but I could put 2 point what?
3.
3, 4, 5, 6, ... Okay, give me a non-perfect square.
5.
5,
Or 7.
or 7, or 11, or 21. Okay? This is going to be very helpful for your homework tonight.
Wait, how is 21 not?
Because a perfect square means that I can take one number and multiply by itself. Is there a number you can multiply by itself to get 21?
Yeah, 7 times 7.
Okay, but would 7 and 3 be a square or would it be a rectangle? And that's what you missed on Friday. So a perfect square means it has to be the same number. But I'm going to show you how to do it on a calculator tomorrow. All right, next page, your blue paper. Mastering the real number system. Keep this out because you're going to want to look at this. All right, there's a question on your homework that wants you to label the boxes. So I want to make sure you know how to label the boxes. What is this box over here by itself?
Irrational.
Irrational. What is this big box? Rational. Remember, every number is part of the real number system until you get in 8th grade, 9th grade, and no, maybe 10th. Algebra 2, maybe you learned about imaginary numbers. Those are not fun. Okay? All right, what's the big circle?
That is integers.
Integers. What's the next one? Whole numbers.
And then natural.
Natural. Because natural numbers are naturally numbers. You count on your hands and your feet. 1, 2, 3, 4, and so on. I won't bore you with the rest. Okay, now that you know how to label them, do you want to do this together or do you want to try by yourself? Together? Okay. Remember, you want to be the most specific. 3. Where would 3 belong? Well, I hear natural and I hear whole.
Natural.
Natural. Is it also a whole number? Yes. Is it also integer? Is it also rational? Is it irrational? No. Okay. 2.09824 ...
Irrational.
Why is it irrational? Never ends. Stop talking. Jeez Louise. Okay. Square root of 25. Is it a perfect square?
Yes.
What number times itself gives you 25?
5.
5. So that would be a what kind of number? Natural. Good. Square root of 24.
Natural.
Okay. So 6 times 6 gives me 36. Is it natural?
No.
No. And again, I'm going to show you how to do this tomorrow on the calculator, but when you do the square root of 24, do you think it's a nice perfect number? 12 times 12? This is a square root of 24,
It's never ending.
which means what?
Irrational.
So all non-perfect squares are irrational. So if it's not one of those perfect squares, then it is irrational. Okay? Negative 100.
Integer.
Integer. Negative 7. Integer. Pi.
Irrational.
Irrational. Negative 1/3.
Irrational.
Rational, yes. A lot of people think integer because it has the negative, but remember we said that integers have to be what kind of numbers?
Whole numbers that you can have.
Whole numbers.
Negative and positive.
Okay. 6.5.
Integer.
It has a decimal.
Rational.
It's rational. Negative 3.01 with the line over it.
Rational.
Why is it rational?
It has lines.
Yeah, it's repeating. And then you probably don't know this one, but 2/7. So starting tomorrow, you would just use a calculator. And what do you notice?
Oh,
It's irrational.
It's irrational because it never ends. Okay? Everybody feel okay classifying?
Yes.
All right. So now we're going to do some true false. All in huh?
What about the 3?
Right here.
No, the 3.7.
Oh, okay.
Okay. All integers are rational.
Yes. Yes.
I hear most people say yes. Okay. All
Out, but you can't come back in.
yes. All negative numbers are integers.
Yes.
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 Oh, no, because decimal.
What about negative 3.7?
Oh, wait, no.
So this one is
False.
Oh, wait.
false. 3.87655. Now, this is a little bit tricky because I could see either answer here. Do you have a line over it showing that it's repeating?
No.
No. Do you have a ...
No.
No. So technically, it's just a regular decimal, which is rational. But I could see why you might think it if it had the ... So it's yes. All right, 7 is a real number.
True.
True, because every number you know in 8th grade is a real number.
It's not imaginary.
Every number is real. All fractions are integers. Give me an example. Okay, 1/2 is not an integer. Correct. All right, all whole numbers are natural.
No. No. 0.
No, you got to remember that 0. Okay, all irrational numbers are real.
No. Yes, she just said every number you learn in 7th or 8th grade is real.
Every single number in 8th grade is real. Okay, and then all rational numbers are integers.
Even 0 is real?
Yes. And an example of a rational number that's not an integer? 6.5. Okay. All right, fold this paper in half. You will notice there's a checklist. We need to do that checklist really quick. Okay. You remember this was a question on GCA. They always put a question like this on STAR. The checkbox. When you're doing the checkbox, when you fold it over, it's just turn your paper. It's on one of the sides. You might not have folded it right. It depends on what you were looking at. Okay. There will be multiple check marks. Okay, this is like you're going to a doctor and they're like, what are all your symptoms? Oh, you have a headache. Oh, you have a fever. Oh, okay. That's what we're doing to this number. We're asking this number, what are all your symptoms? What are all your classifications? Whatever. Okay. Every number in 8th grade is real. So, should every number have a check box, a check under real? Yes. Every single one is real. Okay. So let's start with 0. Is 0 irrational? No. Is 0 rational?
Yes.
Yes. Okay. Is it an integer?
Yes.
Yes. Is it a whole number?
Yes.
Yes.
Is it natural?
No.
No. Are there any questions over that? Okay. 2.07. Irrational? No. Rational?
Yes.
Yes. Integer?
No.
No. Why is it not an integer?
Because it has a decimal.
Yes, it has a decimal and an integer has to be a whole number. Very good. -35. Irrational? No. Rational?
Yes.
Yes. Integer?
Yes.
Whole.
No.
Why?
Because
Negative.
It's a negative. Okay, square root of 17. Is that a perfect square?
No.
No, it's non-perfect, which means it's what?
Irrational.
And if it's irrational, is it anything else?
No.
No. Okay. 7/3. It's 2 1/3. And what do you know about 1/3?
Wait, so it's irrational.
1/3 is a repeating decimal. Where do repeating decimals go?
Rational.
Rational. So it's not irrational. Okay. Is it an integer?
No.
No. It's just a rational number. Okay. 0.4582. Is it irrational?
Yes.
Does it?
It doesn't have the
No,
dots.
there's not
Doesn't have the dots. So it's rational. Is it an integer?
No.
No. Okay. Everybody feel okay with that?
Yes.
Yeah.
Okay. So tomorrow I'm going to introduce you with the calculator and show you how to do it on the calculator. But today was just that vocab. Okay. So you have this paper. Take your white paper and also fold it. And we are going to glue those in our journals.
Wait, Miss Davis, what time is it?
3:20.
Oh.
I forgot you were recording.